everyone, this is Dr. K. Jagannayaki, Professor in MBA Department, Institute of Aeronautical Engineering, Hyderabad. Today I would like to discuss about Cobb-Douglas production function. See, in previous sessions we have discussed what is the concept of production and what are the different types of production functions. So today I would like to discuss about Cobb-Douglas production function, what are its properties, characteristics, limitations, and functions of Cobb-Douglas production function and estimation of Cobb-Douglas production function. So before going to discuss about Cobb-Douglas production function, in the previous sessions we have discussed about what is production. Production is nothing but transformation of inputs into outputs. So here inputs means we used to discuss about the productive resources like men, machine, money and materials. So it is a process of converting input into a more valuable output. The output may be either a good or service. So the analysis of demand is mainly used for planning production process and determining the level of production. So if supply is equal to demand, then we used to set it as an equilibrium position. So production is an aspect of supply side of the market rather than demand side. So production function says that output is a function of input. So it states that the functional relationship between physical inputs and physical outputs. So we used to derive production function. The general function of production is O is equal to, it is a function of NLKT. So it is the combination of all inputs, how we used to transform them into a valuable output. So coming to Cobb-Douglas production function, during 1900 to 1947, Charles Cobb and Paul Douglas, they have formulated and tested the Cobb-Douglas production function through various statistical evidence. The Cobb-Douglas form of production function is widely used to represent the relationship of an output and two inputs. So basically we used to consider two inputs like land and capital. So a Cobb-Douglas production function model, it shows the relationship between output and production inputs. So these inputs are also known as factor inputs. So the factors that are used in the production function, they are known as factor inputs. So it is used to calculate ratios of inputs to one other for efficient production and to estimate technological change in production methods. So it's a commonly used economic model and it is very flexible when you are going to compare with other type of production functions. So the production function for American manufacturing industry using annual time series data for the period 1899 to 1922 by Cobb and Douglas. So it is represented as Q is equal to AK alpha L, where K denotes the capital and Q is known for output and L is denoted as labor. A and alpha, these are positive constants. Coming to the properties of Cobb-Douglas production function, the first function is that it assumes the returns to scale to be constant. So whatever returns we are going to generate at different levels of production, it remains the constant. The constant A and I, 1 minus A, in the Cobb-Douglas production function are the output elasticity of capital and labor respectively. If one of the input is 0, output will also be 0. The value of A and 1 minus A is the returns to scale. If A plus 1 minus A is equal to 1, then constant return to scale will operate. If A plus 1 minus A is greater than 1, then increasing returns to scale will operate. If A plus 1 minus A is less than 1, then decreasing returns to scale will operate. The same we have exhibited in the graph. And elasticity of substitution in the Cobb-Douglas production function is equal to 1. The Cobb-Douglas production function satisfies Euler's theorem, and expansion path generated by Cobb-Douglas production function is linear and passes through the origin. The constant here represent the capital and 1 minus A represent the labor share of the output. Cobb-Douglas production function becomes linear in logarithm, that is log y is equal to log a plus a into log a plus 1 minus a into log L. And coming to the characteristics of Cobb-Douglas production function, the first characteristic is homogeneous production function. So Cobb-Douglas production function is a homogeneous production function. It implies that if the scale of inputs is increased by a certain factor, the output will remain increased by the same factor. For example, if you are going to increase the input by 1%, the same increase we can expect in terms of the output also. So that is known as homogeneous production function. They used to maintain the same level of production. The degree of homogeneity depends upon the returns to scale. It is a homogeneous function of degree 1 if there are constant returns to scale. So the same we have derived by using these equations. Q is equal to AL whole to the power of alpha and K to the power of beta. Suppose the scale of inputs increased by alpha factor of T, then Q star will be A into T into L whole to the power of alpha, T, A whole to the power of beta. So if you simplify this, we'll get the new output. Q star is equal to T to the power of alpha plus beta comma Q. It is a homogeneous of degree alpha plus beta, and it is homogeneous of degree 1 if alpha plus beta equal to 1. Then second characteristic is output elasticities. The output elasticities with respect to labor and capital are shown by their powers in the Cobb-Douglas production function. Hence, the value of alpha shows the output elasticity with respect to labor. And this can be easily proven using the formula for calculating elasticity. So, EL is equal to alpha. Then marginal products and law of diminishing returns. The Cobb-Douglas production function follows the law of diminishing returns to a factor. As more of an input is employed in production, keeping the other input constant, the marginal product of these successive units of that input will go on decreasing. For example, the marginal product of labor will go on decreasing as more labor is used. So given that capital stays the same, there is no change in terms of capital, but we can see that there is a change in terms of labor. Then marginal product can be expressed in terms of average products. The marginal products of inputs are related to their average product in the Cobb-Douglas production function. The marginal product can be easily expressed in terms of the average product of input as follows. So, APL, it is nothing but output divided by the given input, whereas marginal product is denoted as MP, and average product is denoted as AP. So, therefore, APL is equal to Q by L and APK, average product of capital, is equal to Q by K. So hence MPL is equal to alpha into APL and MPK is equal to beta into APK. Therefore, we can observe that marginal and average products are related by their respective output elasticities alpha and beta. Average product can be expressed in terms of the capital output ratio. If there are constant returns to scale, the average product of labor and capital can be expressed in terms of the capital labor ratio. So average product in terms of capital labor ratio is denoted as APL is equal to Q by L, which can be further simplified as A into alpha to the power of L to the power of alpha and K to the power of beta divided by L, assuming constant returns to scale, or L plus B, alpha plus beta equal to 1. So if you simplify this, we can prove that APL is equal to A into K by L whole to the power of beta, and APK stands for A into K by L whole to the power of alpha. So this is applicable only in case of constant returns to scale. In other cases, the formula may vary. The next, MRTS, which is also known as marginal rate of technical substitution. It means that technically we can substitute one factor with other. So as we are going to talk about two factors, one is capital, another one is labor. So technically we can substitute capital with labor and labor with capital. So it shows that the amount by which one input must be reduced to increase the other input by 1 unit to produce the same output. In other words, it shows that the trade-off between inputs. For example, MRTS will show the amount of capital that must be reduced to increase the labor by 1 unit and still produce the same output. And further, the MRTS for the Cobb-Douglas production function can be derived as marginal rate of technical substitution is equal to delta K by delta L, which is further simplified as MPL by MPK. Estimating the Cobb-Douglas production function. So one of the further advantages of the Cobb-Douglas production function is that it is easy to estimate in practice. We can estimate it using the method of ordinary least square after taking the logarithmic function. The parameters a, alpha and beta of the function can be estimated as follows. Qt is equal to a l t to the power of alpha k t whole to the power of beta. Taking log on both sides, log qt is equal to log a plus alpha into log lt, beta into log kt plus mu t. So where t is the given time period, qt is the output, a is the efficiency or technology parameter estimated as the constant, and alpha is the parameter of output elasticity with reference to labor, and beta is the parameter of output of elasticity with reference to capital, and mu t is the error term. This equation can be easily estimated using ordinary least squares. Here the estimated coefficients of the model represents the parameters of the Cobb-Douglas production function. We can also assess whether the data shows constant, either increasing, decreasing returns to scale. So this is easy to find out using the estimated coefficients of alpha and beta. If alpha plus beta equal to 1, it means that constant returns to scale. If alpha plus beta is greater than 1, there is an increase returns to scale. Finally, if alpha plus beta is less than 1, it means that decreasing returns to scale. Just by focusing on alpha plus beta, we can able to analyze what kind of returns to scale. And coming to the limitations of Cobb-Douglas production function. So, although Cobb-Douglas production function is widely used and it has certain limitations, elasticity of substitution is one. So, this is one of the major drawback of Cobb-Douglas production function. Its unit elasticity of substitution makes the function very restrictive. In reality, the elasticity of substitution is not 1, but it changes with a change in the level of input. As a result, the Cobb-Douglas production function is not flexible in respect at all. Then second one is constant technology. The production function assumes that the technology parameter A to be given and constant. It means that we cannot study or analyze the changes in technology and its effects using the Cobb-Douglas production function. So industries that witness rapid technological changes cannot be suitably analyzed using this function. Then third one is static nature. As with static technology, Cobb-Douglas function does not take into account the dynamic market conditions and their effects on output. So there are so many factors that influence the production process. So it may not consider being the static nature. It never considered that kind of rapid technological changes and also the market conditions and their impact on overall output. So it cannot be used to understand how firms make adjustments to their output to changing input prices and other market conditions. Then aggregation bias. The function assumes that all the inputs of the same type are identical and interchangeable, which is unrealistic. For example, any two units of labor are not the same or identical. Even after considering the various shortcomings or limitations, the Cobb-Douglas production function is a useful and essential tool. It has motivated the development of several production functions over the other functions, such as apart from Cobb-Douglas, we have CES, VES, and transfer production functions have attempted to remove some of these shortcomings. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.